So our problem is finding the state transition matrix of this system. Before we do that, let us find the formula we will use in finding the state transition matrix. So state transition matrix donated by pi of t is used in finding the state of a system at time t given the initial state of the system s of 0. So mathematically we know that s dot is just ax plus bu, but for a pre-system, that is a system without an input, it will reduce to s dot is equal to ax. So finding the Laplace transform of this equation that is converted from time domain to s domain, I will have this relationship. Collecting like terms, it will reduce to s I minus a, where I is identity matrix. It is multiplying s because we are dealing with matrices. Therefore, multiplying both sides by si minus a inverse, I will have this equation in s domain. Then taking the inverse Laplace transform, that is converting it back into time domain, I will have s of t is just Laplace inverse of si minus a inverse s of naught. So comparing 3 and 2, that is this equation and this equation, it is clear that my pi of t is just Laplace inverse of si minus a inverse. So in order to find the state transition matrix pi of t, I need to know my a. So from 1, this is the matrix that represent a. Then in order to make things easier, let z be si minus a inverse. So I will have this relationship. My identity matrix is 2 by 2 because I am dealing with a 2 by 2 matrix that is a second order system. So solving, I will have this matrix as z. So now in order to find z inverse, which is si minus a inverse, I will use this formula, which is the formula for inverse, that is adjoint of z divided by determinant of z, which is equal to cofactor transform over z determinant. So my determinant of z, I will have just x times s plus 3 minus 2 times minus 1, which will give me s into s plus 3 plus 2. Opening up this, I will have s squared plus 3s plus 2, and factorizing, I will end up with s plus 1 into s plus 2. So now I need to find my adjoint. To find adjoint, you need to find the minor of z, that is the minor of each element. So the minor of z is this. How did I find this? So what you do is you'll go to z and you'll close the corresponding row and column of each element. So for s, it is in row 1, column 1, so I will close row 1 and column 1, and I will be left with s plus 3, which is this s plus 3. For minus 1, I will close row 1 and column 2, and I will be left with 2. So because 2 is in second row, first column, I will close the row and the column, and I will have minus 1. So likewise for s plus 3, I will do the same thing. I will close this column and this row, and I will be left with s. So that is how to find the minor of z. The next step is to multiply this matrix with the appropriate signs in order to find the cofactor. So the signs are alternating. So I will have plus, negative. If it is third order, the next sign will be positive. So likewise for the column, I will have positive, negative. You will see negative, positive, so it is alternating. So applying the signs, my cofactor will just be, because s plus 3 is multiplied by plus, I will just have s plus 3. And because 2 is multiplied by minus, I will have minus 2. Minus 1 times minus 1, I will have 1, and plus s will just be plus s. Now I need to find the transpose of the cofactor, and transpose is just about switching rows with column. So you see my row will turn into column. So s plus 3 minus 2, and this row will turn into the second column, which is 1 and s. So I already have my cofactor transform and my determinant from 7 and 8. So I just need to substitute them into 6 in order to find my z inverse. And doing that, I will have this matrix. And as you can see from 4, now I need to find the Laplace inverse of each of these elements in order to find my state transition matrix. So in this form, we need to break them down into components for us to be able to easily find the Laplace inverse of the elements. So each element, I will have to take it down and then break it down using partial fraction to have it in a simplified version. So taking the element in the first row and first column. I'm breaking it down using partial fraction. I will have a over s plus 1 plus b over s plus 2, and taking s plus 1 and s plus 2 as my denominator, I will have a into s plus 2 and b into s plus 1. So multiplying this part and this part with s plus 1 and s plus 2, I will just have s plus 3 is a into s plus 2 plus b into s plus 1. So now let s to be equal to minus 2. So now it means I want to eliminate my a. Had it been I want to eliminate by b, I will let s to be minus 1. If you put minus 2 plus 3, you have 1. So minus 2 plus 2, a will be eliminated, and minus 2 plus 1 is just minus b. So it means b is equal to minus 1. So now I can let s to be anything. So let s to be 0 for easy solution. So I will have, again in this equation, I will have just 3. Then 0 plus 2 is just 2a. I already know my b is minus 1. Into 0 plus 1, I will just have minus 1. So I have my a, I have my b. I just need to substitute them back into this partial fraction, and this will be my first element broken down into this simplified version. So again, I need to do the same for each of the elements in this equation. So I will leave that to you. I will just give you the solution. So doing that for the other elements, I will have my z inverse as this matrix. So now I need to find the Laplace inverse. As you can see, for set transition matrix, I need to find the Laplace inverse of each of the elements. So using this table, if I have an S domain of 1 over s plus a, then the inverse Laplace transform will just be exponential of minus 80. So applying that to this equation, so I will have this solution. As you can see, I have applied this table to this because s plus 1 will just be exponential of minus t, and s plus 2 will be exponential of minus 2t. So I will have 2 exponential of minus t minus exponential of minus 2t. If I take the element in the second row and second column, so this one is just s plus 1, it will be exponential of minus t, which is minus exponential of minus t. And here I have plus 2 over s plus 2, which will turn into exponential of minus 2t. If you want to learn how to convert state space equation into transfer function, watch the video on the screen. Please like and subscribe to the channel if you enjoyed the video. Thank you for watching.